Dear student, welcome in CEC Gurukul lecture. We are in the series of experimental physics in which we are discussing the sum of experiment of optics. In this series today we will discuss the experiment which is based upon the polarimeter. So, I am Dr. Sonia Bansal from JC Bose University of Science and Technology, YMCA Faridabad. Today's topic is the polarimeter. Polarimeter experiment we will discuss today. Now, the aim of the experiment is to find out the specific rotation of sugar solution by using Lorentz half shade polarimeter. As the aim suggests that we are calculating the specific rotation of a optical active substance, that is the sugar solution, and the instrument we use is the polarimeter, which used Lorentz half shade crystal. Now, who discovered this? If we talk about the history, then Louis Malus in 1808 defined the polarization by reflection. Basically, he conducted the experiment to verify the Huygens theory of light, and he explained the theory in analytical form by discovering the polarization of light by reflection, how the light is reflected through polarizer. So, the polarization of light by reflection given by Louis Malus in 1808. Now, what apparatus we use in this experiment? The main is the polarimeter. The whole setup is called as a polarimetry. Polarimeter we use the sodium lamp. Sodium lamp is used to illuminate the optical active substance. Second is the sugar. Beakers we use graduated jars, weight box, balance, and we use the polarizer, we use the analyzer, and then eyepiece we use in this experiment. Now here in the instrumentation of this experiment is, you see on the screen that on the left hand side we are having the light source. After that we are having the polarizer, then a quartz tube which contains the optical active solution, then we have a analyzer or the eyepiece. So, in this optical active may be detected and measured by an instrument. That instrument is known as the polarimeter. So, this is the polarimeter, which consists of basically part light source, second is the polarizer, then we have a tube where we put the sugar solution, then we use the analyzer, then eyepiece just to get the reading. Light source may be of the sodium lamp. Just usually we use the sodium vapor lamp, and analyzer, for the analyzer we use the Nicol prism, which is aligned to intercept the linearly polarized ray at its emerge from the sample solution. Means the first part is a polarizer, the last part when the light emerge out from the sample, then we use the analyzer just to get the output. Polarimeter consists of polarized light source, sodium lamp, polarizer that is made of the quartz prism material, and analyzer is also we can have that of the similar form like quartz and prism. The Nicol prism aligned to intercept the linearly polarized ray at emerge out from the sample solution. So we use the two Nicol prism first as an analyzer, and second is the polarizer as just to get the specific rotation of a optical active solution. So, what is the polarimetry? First, we discuss the sum of the definition which is used in this experiment. Now, what is a polarimetry? The term polarimetry may be defined as that we are just using it and we are studying the rotation of polarized light by the transparent substance. Transparent substance means the solution, basically we use the solution must be of optical active, so that light can pass through it and we can find out the output, or we can find out the rotation of polarization when the light pass from this transparent solution. So, polarimeter is defined as the study of the rotation of the polarized light by transparent substance. Optical rotatory power is useful for quantitative analysis as well as qualitative analysis. We can find out the chemical structure. Basically, we just convert the ordinary light into the polarized light, and we are finding the direction of polarization of the light as it is rotated through the solution. So as we know that ordinary light is usually vibrate in all the planes, that is, it is called a unpolarized light. And when it is polarized in one direction, when it is vibrating in one direction, that is the polarized light. The vibration may all be restricted to one direction only in the perpendicular plane, then we call it as a plane polarized light. Unpolarized light gets converted into the plane polarized light by passing through the Nicol prism, and then we pass the unpolarized light from the Nicol prism, then we can get the polarized light. Means the Nicol prism are made of the Eisenspach calcite, and Polaroids we can also use to polarize the light from the source. As the sodium light is unpolarized light, when it is passed from the polarizer, then we can get the plane polarized light. On the left hand side is here is the unpolarized light, polarizer is used, and then we get the one direction of the light, that is a plane polarized light. It is on parallel or the perpendicular of the plane of polarization. So here see on the bottom diagram we are having the two polarizers, one is polarizer and another is an analyzer. So light, unpolarized light from the first polarizer, then vertically it passed from it, and then polarized light we will get. After that it passed from the horizontally polarizer 2, then we can get only the output must be of the single direction light we will get when it passes from the polarizer as well as the analyzer. You see, longitudinal and transverse wave pass linearly polarized light, then only the single direction we will get. The end view we see the simple one plane light we can get. It may be of the plane of polarization. The plane polarized light, which consists of two components, fixed magnitude rotating in the opposite direction to one another, one in the clockwise and second is the anti-clockwise. The right circularly polarized light we can say, and second is the left circularly polarized light. So plane polarized light is the vector sum of these two components, right circularly or left circularly. What is polarimetry? Polarimetry is the measurement and interpretation of the polarization of transverse wave. As the light passes from the polarizer, then from the sample, then the analyzer, the output that is polarized, that means the light is rotate or light changes direction, that we can find out through the polarimetry. Polarimetry is one of the best instrument which is used for analysis of a direction of the light, polarized light. Polarimetry is very sensitive and non-destructive techniques for measuring the optical activity compound. By using this experiment, we can find out the material or the compound is optically active or optically inactive. So one of the aim of this experiment, by using this we can find out the compound or the solution which we are using is optically active or optically inactive. If we get the rotation of the polarized light, or we can find the change in the direction of polarized light, then it is an optically active substance. If there is no change, that it is not a optically active compound. So this technique involves a measurement of the change in the direction of the vibration of polarized light when interact with an optically active compound. As the light emergent from the analyzer, if it changes its direction of vibration, then the material which we are using or the compound in the tube must be of the optically active. So this technique used to find out the direction of vibration of the polarized light. Also, a substance is said to be optically active if it rotates the plane of the polarized light. the substance is said to be optically inactive if it doesn't rotate the plane of polarized light. So by using this experiment we can find out. This instrument measures the rotation of the polarized light as it passes through the optically active substance and tendency of the molecule to rotate the plane polarized light towards the clockwise or anti-clockwise direction, whose extent the rotation can be measured. It means the optically active substance, when the light passes from the optically active substances, then the molecule will vibrate and then it will rotate the plane polarized light, and the emergent light must be clockwise or in the anti-clockwise direction. In principle, a pair of the crossed polarizer, the pair of their path axes perpendicular to each other, may be used as in the polarimeter. So we use the polarizer as well as analyzer in the experiment. No light will emerge from such a combination if we are having the same. You see that if both are perpendicular, one should be perpendicular and second should be parallel to the axis. If a optically active substance is introduced between them, the plane of polarization of the light out from the solution may be rotated by a certain angle, and it pass from the second polarizer will not be able to block the light now. So it means the light pass from the polarizer, then from the solution, then its angle will be changed, and the next polarizer will not be able to block the light now. It means we are having the single direction light. Now we see on the diagram here, the second polarizer will have to be rotated by an angle in the same sense as to make the field of view dark again, so that we can find out the output. You see the light source, unpolarized light pass from the polarizer. You see a single direction, a single arrow is passed from this sample tube. The sample tube contains the active medium, optically active solution, optically active compound. Solution may be solvent or solute may be added. After that it passes, you see here the straight line, after that the arrow is changed by some angle. That angle we can seeing that there is a change in the direction of the polarized light. At this angle light pass from another polarizer, then you see at the output we are having the same angle. It means the second polarizer will not block the previous one, and then we can find out the output, or you see the change in the direction of polarization we are getting. Similarly, if there is a change, then it is a optical active. It means solution we are using is optical active solution. So this is the schematic diagram where we are having the light source, polarizer, tube where we put the solution, then we have a analyzer and then eyepiece. So the analyzer will analyze the light which is polarized emerge out from the solution. Now the angle of rotation can thus be measured by fitting a circular scale of the second polarizer. So for adjustment we can take it. The further we will discuss regarding this, how we can get the different angles at different solution when we will put into it. Now just I tell you example. If we use the water, then light pass from the water, then we can get the some angle of the polarization. When we mix the sugar in that water with a particular concentration, then you see the angle of polarization will change. Then we note the reading. So we take the difference between these two readings and we can say that how much angle is rotated for the pure water as well as the water mixed with the sugar solution. In this way, we can find out the change in the direction, change in the angle of polarization. From here, we can find out that the water as well as when we put the sugar solution, the solution must be optically active. So, the angle of rotation can thus be measured by fitting a circular scale to the second polarizer, then output we will get it. This is the basic diagram. Thus here we clearly see that how the polarized light angle is rotating. You see the light source, left hand side we are having the light source after it pass from the polarizer, in between that we are after polarization, light will be the light pass from the polarizer, we get the polarized light. This polarized light pass from the polarimeter tube, which contains the optical active substance. The length of this tube approximately 10 centimeter long. Then it pass through the polarizer again when it comes emerge out from the tube. Then we see that angle of rotation will be adjusted through the analyzer, so that the exact reading we can find out. So this is the basic arrangement of polarimeter to get our aim out. Now, what is polarimetry? This is an instrument, analytical method using the rotation of the polarized light by some substances as measure of their concentration in the solution. It means concentration just plays an important part, how much concentrated solution we are using to get the output also. So this polarimeter instrument is used to find out the rotation of polarization of the light of a particular substance which is optically active, and we can find out the concentration of that solution. That instrument is called the polarimeter. In the what is the principle behind the polarimeter? It converts the polarized light into the unpolarized light into the polarized light. This is the principle. Unpolarized light from the light source is first converted into the polarized light. This polarized light pass through the sample cell. Then that sample cell contains the optically active substances. Then the plane of polarization light is rotated because of this rotation in the optical active substance molecules. The rotation is noticed by looking through the analyzer as a change in the intensity of illumination, and that will gives the change in the angle of polarized light, and that we can measure by the vernier scale as well as the main scale. What is the optical rotation? The compounds containing asymmetric carbon atom rotates the plane of polarization. That is the optical rotation. When the plane of polarization angle will change, then the process is called the optical rotation. The phenomena is called optical rotation, and such substances are optically active compound. It is only possible in the optically active compounds. By measuring the angle of rotation, concentration of substance solution can be determined. Now next is the measuring of the optical activity. Now how we can calculate the change in the angle of plane polarized light? Now when the rotation is quantified using a polarimeter, then it is called the observed rotation. How much rotation we are observing? This rotation is affected by the path length, means length of the tube, concentration of the solution, that is represented by C, length of the tube represented by L, and temperature also. It depends upon the temperature also. When these effects are eliminated as standard for comparison of the molecules, then we can find out the specific rotation. Optical rotation means specific rotation, that sometimes is denoted by the alpha. Then alpha is equal to 100 alpha by C L. C is the concentration and L is the length of the tube. When concentration is expressed as a gram sample per 100 ml solution, specific rotation is physical property like boiling point and sample, and look for the reference text. So this is the basic formula. Now specific rotation for a sugar solution formula, what we use generally in the laboratory and how we will do it. Then the angle of rotation produced by the optical active substance depend upon the some factors. Number 1, thickness of the substance, means concentration of the solution. Number 2, one is the concentration, second is the length of the tube, how much long tube we will have where the light, polarized light will pass through it. Temperature is one of the factor. Then if the temperature will change, angle of rotation will change. The wavelength of light we are using, means the light source we are using, also affect the direction of the polarization, or the angle of polarization will be changed as we use the various light. Generally we use the sodium lamp in the laboratories. Optically active substances measure the specific rotation. Basically it is a specific rotatory power. The specific rotation of the sugar solution is determined by the formula generally we use in the laboratory. S is equal to theta, that angle we are calculating when the light pass from the analyzer. the emergent light from the analyzer, that the angle we measure by using the main scale as well as the vernier scale. So specific rotation we can find out S is equal to theta divided by LC, where theta is the rotation produced in the degree, L is the length of the tube, that length of the tube generally we take 10 centimeter, and C is the concentration of the active substance, that is represented in gram per cc in the solution. So the unit degree per decimeter into gram per centimeter cube. If the length of the solution is in centimeter, then the formula will be S is equal to 10 theta divided by LC, where C is the mass of the substance and divided by volume, means concentration we are defining here. The specific rotation 10 into theta into V divided by L into M. So by using this we can find out the specific notation of a solution. What is the Lorentz half shade polarimeter? As the aim explained that we are finding the specific rotation of sugar solution by using the Lorentz half shade polarimeter. What is this Lorentz half shade polarimeter and what is its function, that we will discuss. Why we will use in this experiment, how we can get the emergent light when it is passed from the Lorentz half shade. Then what is the purpose of this polarimeter, Lorentz half shade polarimeter? In this experiment we are using the Lorentz half shade, which is made upon of the quartz as well as the glass. And in this experiment arrangement we use a monochromatic extended light, as we discussed. Sodium lamp we are using, whose wavelength is 589 nanometer. A convex lens to make this sodium light parallel and falling on the Nicol prism. Basically Nicol prism is a polarizer. Nicol prism we use as a polarizer. Then light passed through this Nicol prism, it becomes a plane polarized light. Polarizer will polarize the light, and then the light which is coming from this Nicol prism is the plane polarized light. After that, this light passed through the Lorentz half shade plate and then enter into the sugar solution. Now the plane polarized light transmitted through the another prism called the analyzer. When it passed from the sugar solution, then again it passed from one of the polarizer. That polarizer is known as the analyzer. That is also is the Nicol. That is also the Nicol prism. The analyzer is rotatable. We can rotate, we can adjust the plane polarized light propagating through the liquid and reach to the eyepiece. Then we note down the reading of this rotation in degrees, and that will be measured from the vernier scale as well as the main scale. Thank you very much.